Good afternoon, everyone. Thanks for joining our Zero Trust webinar featuring OpSWAT, hosted by Ingram Micro's Emerging Business Group. My name is Carleen Edge, Marketing Manager here at EBG. Today's training will last approximately 50 minutes, and just in terms of general housekeeping, your lines have been muted for the duration of the presentation. If you do have any questions, please feel free to type them in the Q&A box on your screen, and we're going to address all questions at the end of the presentation. Today, we're also going to be recording the training, so I will send out a recording link to everybody in our follow-up correspondence. So let's go ahead and hand things off to Jerry Dietrich, Cybersecurity Technology Consultant at Ingram Micro. Jerry, take it away.
Thank you, Carleen, and thank you to everybody for attending. Today is our final webinar in a series of 4 that covers the Zero Trust space. And again, I want to thank everybody for taking the time. I usually cover this with my partner in crime, Jimmy Augustine, but he couldn't make it today. But I do want to ensure that everybody knows that Jimmy is our Chief Technology Evangelist, so it means that he travels the country and works with our partners to ensure that everybody is aware of the technology solutions that Ingram can help bring to the table. So I wanted to just kind of cover that with y'all. Today's session is really a unusual and unique session because we're going to work with a partner that works in industrial controls, and that's our friends over at OpSWAT. Here's a quick agenda, and I wanted to just kind of get to the matter of things here. We've had 5 partners that have worked with us on this series, and I want to thank all of them for their participation. And they've all brought something unique to the sessions. Today we're going to talk with Amit Schulman at OpSWAT. And before we get started with Amit, I just wanted to take a second and just kind of cover what we're doing here with Zero Trust. You know, folks ask, what is this? Because it's got a lot of hype in the market. There's a lot of misunderstanding. So in a nutshell, what we want to do is just have everybody be on the same page that with this is an operational philosophy that your clients are looking to potentially adopt, and we want them to know more about it. And what it's doing is combining least privilege software and hardware and different products and policies and processes in a way that allows users to only access resources in their environment that are required when they need them, while the systems check the state of the user's machines, who they are, time of day, and different criteria. So that's pretty much it in a nutshell. If you really want to read and understand, here is it's the NIST 800-207 standard, and there's plenty of information on the NIST website about that. But we won't go into that there. Here's where OpSWAT lives in the continuum of Zero Trust. So we have software-defined perimeters, and they also have the ability to watch for unusual user device behaviors, and also monitor and report on unusual server network traffic. They have sandboxing. They have a number of different technologies that all enable a good Zero Trust posture. So without any further ado, what I'd like to do is turn it over to Amit, who is the subject matter expert for us. And we'll go ahead and make him a presenter and let him take it from here.
Thank you very much, Jerry, and thank you, the Ingram team and everyone that joined us today. Let me share my screen here and we can get started. So, my name is Amit Schulman. Nice to meet you all. I've been at OpSWAT for almost 7 years now. Most of this time I worked directly with customers. I'm going to share some of these stories today with you. And going to introduce you to OpSWAT. What are we all about? What is it that we do? And like Jerry said, we're doing a lot of things, and most of them are pretty unique to OpSWAT. So OpSWAT's mission is to protect the world's critical infrastructure. And we'll talk a little bit what critical infrastructure means and what OpSWAT can do to help you gap between that world of IT and OT. So a lot of things to cover today. So a little bit about the company. OpSWAT was founded 20 years ago in 2002, and the first product the company develops is a framework. It's called Oasis. And that framework essentially gets information on devices, right? What AV do you have installed? You have your firewall enabled, did you encrypt your hard drive, things like that. And really the first customers are OEM customers. So Cisco, Palo Alto Networks, Juniper Networks, Aruba Networks, McAfee, Trend Micro, that goes a long way. These are all still customers of this product. And if you ever had your hands on NAC or SSL VPN products before, and you saw an option there to scan the device before the user logs in, that's OPSWAT's technology embedded into all these products. 2007, OPSWAT develops and releases the MetaDefender platform, focusing on file security. So anything around detection of known malware, prevention of unknown malware, detection of sensitive information, anything that can make us comfortable to use a file and ingest that to our systems. That's really kind of the first step of the company into the critical infrastructure protection world. About 2-3 years after the company released MetaDefender, 95% of the nuclear power plants in the United States are using this platform to scan any file that they bring into their most sensitive environment. 95% really means all of the nuclear power plants except for one that decided to build an in-house solution. They had their own challenges there, and we're not gonna touch that too much today. Fast forward to 2020, OPSWAT acquires Impulse to expand our MetaAccess offering, and with that provides a complete solution for secure access. So like I mentioned, not only we can check the device that's logging into our systems, but now we can apply that technology to anywhere where a device can really connect. That can be physical networks, that can be cloud-hosted applications like AWS or Salesforce, for example. 2021, OPSWAT acquires Bayshore Networks, and with that, we get a step into the OT environment. So not just the fires that going into that environment, but with the Bayshore Networks products, we can now be part of that network and help to protect it as well. OPSWAT is a global company, from sales to R&D and marketing, and of course our customer success team, allowing us to cover 24/7 support for our customers. So let's talk critical infrastructure and what that really means. The government in the United States broke this down to 16 different sections, let's say, and it can be from anything like our train system and bus stations and so on, to water treatment facilities, power generation factories, and of course, many others. So if you think about defense and so on, the real definition here is anything that could potentially affect our day-to-day life, right? So that can be hospitals, and that can be our supply chain of food, for example. We also break down these environments based on the impact of that environment, right? So we might have high, medium, or low impact environments. Obviously, if something happens in a nuclear power plant, the consequences can be much more serious than if we're talking about a transportation system, for example. So why does this matter? Obviously, critical infrastructure, these are high-profile companies. Hackers, and when I say hackers, I normally talk about state-backed hackers that have the knowledge and the resources to go after that type of infrastructure. This is a real snippet from a website, CSIS. You can now go to that website and see the latest breaches. Some of the things we can highlight there, I just looked today, just kind of out of curiosity before this session. And a couple of the interesting things I've seen there, for example, in June, 2 months ago, FBI, NSA, and CISA announced that Chinese state-sponsored hacker groups breached major telecommunication and network service providers in 2020. So these guys breached all these companies that own our phone systems, our mobile network, our internet systems, and so on. And they stayed there for 2 to 3 years before we even found out about that. So when you think about hackers, their challenge is not just to breach the environment, but to stay still as long as possible, stay there without being detected, and of course, get the data out without that company or whatever environment they breached into noticing and then blocking this attack. Right? The consequences of these attacks can vary from fines, for example. So NERC is the organization in the United States that regulates power generation. And that includes the most critical ones like nuclear power plants. So you're gonna hear me repeat that a few times today, but that's probably one of the best examples we can talk about. So we can talk about something as simple as not being compliant with the regulation and being exposed to heavy fines. And these fines can go up to the millions. But consequences can also be a little bit more serious than that, from disrupting operations in a manufacturing facility, where you can take it down for weeks. Can tell you last year, a hospital in Israel got impacted by a ransomware, bringing it down for weeks. They had to go back to pen and paper, and I probably don't need to tell you what that means for a hospital today, where even the beds and the monitors and so on, everything is connected to the network. The things that are more serious, like, for example, the example you see on the left here, water treatment facility in Florida, Iranian hackers get access to the system and trying to change the chlorine levels in the water, essentially trying to poison this entire community. Luckily, this one was caught just in time, but they did manage to infiltrate that network. So there's also worst case scenarios. I can tell you probably one of the worst cases I heard about was about 2 years ago in Germany, couple months after COVID hits hard all around the world. Hospitals are already overloaded, and a hospital in Germany got hit by ransomware, bringing down pretty much all of their systems, which in turn, what happened, they had to transfer one patient to another hospital, and that patient didn't make it all the way to the hospital. So the consequences of these cyber attacks are very, very real. So I'd like to talk to you about what does an environment look like when we're talking about IT, OT, manufacturing environment. And I will use the example of Stuxnet. So hopefully, if you're not familiar with Stuxnet, will keep you interested a little bit longer, but I also like to use that example to visualize what are some of the possibilities when we're talking about in an environment like this one and what attack surfaces we have here. So most of the manufacturing environments today, they'll follow what we call the Purdue model, which is what you see here. The Purdue model essentially divides our networks to different segments in efforts to protect these networks. So I don't want my accounting team that sits in the office and connected to the outside world, to the internet. They're accepting emails from who knows who, and we don't want any chance that, for example, this group can have any effect on our manufacturing environment, right? So most of these environments will segregate these networks in a way that if someone got a malicious email and infected the entire office, it's still not going to affect our operations and the actual pumps and centrifuges, the controllers, whatever it is that we have in that factory, right? So what is Stuxnet? Stuxnet is probably one of the more well-known or notoriously known malicious softwares that ran in an operational network. So what happened there? We're talking about a nuclear enrichment facility in Iran. So we're not talking about nuclear power generation anymore, but actually manufacturing nuclear bombs. An engineer walks up to the engineering station. So this is how we interact with, again, centrifuges, pumps, or whatever machines we have in that environment, and give the orders what exactly do we want those machines to do. So an engineer walks up to the station and plugs in a USB. That's all they had to do to get this attack started. They plug in a USB. As soon as they plug it in, the USB automatically runs a script. They didn't have to open any file or anything like that. And that script, what it did next is deploy our malicious software. So that software had a very specific target in mind. That software wanted to find the one controller that controls the speed of the centrifuge. Now, we said the idea is not just to infiltrate the network, but to stay quiet long enough to actually get to our target and execute whatever it is we're trying to do in this attack. So software is launching and starting to replicate itself and jumps from one system to another. And every time it goes to a system, it's not executing anything, but it's looking at the system, different information that's available, and trying to understand what exactly that system is doing. So essentially, we have a software that jumps from one system to another and says, hey, are you the controller that controls the speed of the centrifuge? If not, I'm just going to jump to the next system. I'm not going to execute anything, and with that, avoid detection. Essentially, eventually, we get to the one controller we're looking for, and we start to execute the commands. The challenge here is these controllers, they speak their own language, right? It's not like you think about the internet, we have the HTTP protocol. Any browser can speak HTTP, and you can go ahead and access whatever website you want through that. So these controllers, they work a little bit different. They have their own protocols, their own language that they're speaking. So if you have a Siemens controller, you won't be able to speak to a General Electric controller, for example. So these hackers knew exactly what controllers are in that environment, and they know exactly how to give commands to change whatever that controller is doing. What really happened in this attack is that they changed the speed of the centrifuge to significantly delay the manufacturing process. And again, they did that for a few months, and the reason they did that, and nothing more serious than that, is that they tried to stay stealth and undetected. So that is the Stuxnet, kind of the worst nightmare of any OT environment. So let's talk a little bit about why this happens. First of all, IT and OT are two different worlds. Normally, your IT engineers will have nothing to do with the OT environment. And if you think about that, I worked with one of my customers. They have their engineering team that's in charge of the entire water and electricity flow for an entire county, millions of people, right? They are not going to take any chances that a printer that wasn't updated in the office is going to affect anything in that process. So these guys are doing their own thing. They know their equipment very well, but they don't know cybersecurity very well. And normally it's the IT groups that are a little bit more on top of this game. So it's relatively new, right? We have to protect these machines, and there's not a lot of connection there. We talked about proprietary protocols. If I want to protect a controller from anyone that's trying to do something malicious with it, I need to know the exact language that controller is speaking. So it's very hard, almost impossible, to come up with one solution that can be applied to all of the manufacturers of different controllers. Right? Then complex regulation. So here I want to share a quick story. I'm going to check my cell phone time really quickly. So a few years back, I mentioned we worked with pretty much all of the nuclear power plants in the States. The NRC, the Nuclear Regulatory Committee, these guys are sitting there and they find out today that there's a new way to exploit, let's say, a Siemens controller, just as an example. Now we're talking theoretically, given the right conditions, this attack can be made. They go back to the nuclear power plants and tell them, hey, we found this possible attack surface and you got to protect yourselves from it. And that's all they tell them, right? We found the issue, you come up with the solution. They don't tell them how to solve that. Well, it happened that this one vulnerability they found, that potential attack, that's where they use OPSWAT, and these nuclear power plants go back to the NRC and say, hey, there's no solution in the market. There's literally no way to solve that problem. The closest thing we have is OPSWAT. And we ended up working with the NRC to actually create some of these regulations and help them audit that later with our customers, because there's really not one easy way to actually protect that. So the regulation can get very complex, obviously zero tolerance. So even if something is theoretical, they expect whichever company that's regulated by them to solve that issue, whichever way, they don't care how, right? So not making it easy to solve these problems as well. Technology gaps, prevention based on detection. That's probably one of the biggest things I can preach here. There is no one perfect solution out there that can detect everything. Just doesn't exist. Part of what OPSWAT is doing is what we call multi-scanning, where we're using multiple AV scan engines from known vendors, right? We work with CrowdStrike, Microsoft, Trend Micro, you name them. 7 years in the company, I worked with more than 50 different vendors. Probably most of them you never heard about. And the fun fact, that Stuxnet malware I mentioned earlier was detected by a company called VirusBlock ADA. It's a small AV company out of Belarus. Never heard about them before I started working at OPSWAT. And I can tell you, tell me which AV you're using, I'll show you how I can bypass that. It's really that easy. So we need to find another solution that's not relying on detection. Also, these products can get pretty complex when we talk about manufacturing environments. These people are most likely not programmers. They're not IT engineers. And there's no dedicated tools that will make it easy on them to deploy cybersecurity solutions in such a complicated environment. And the last is training gaps, where there's really not a whole lot of training available out there to help even just bring the awareness what's the possible risks in this type of environments. So how does OPSWAT address some, not all of these challenges? So first of all, gapping between IT and OT, we have the technology, the experience, and we have some good examples to show how we can actually bring those two groups together through a single platform and giving visibility, for example, to the IT team. If you think about it, you want to be able to respond pretty easily and quickly to any event that might happen in your manufacturing environment. That can include, for example, I don't know, send an email alert to the right people. And a lot of time that means that we need to work with the IT team as well to make these kind of things happen. Deployment should be flexible. So like I mentioned, each environment can look different. OPSWAT solutions can be based on hardware, software, hosted solutions, and they're all integrated by design. So out of the box, I can connect all these systems and secure them from a single spot, from a single vendor under one umbrella. Technology that's purposely built for SIP. So for an example, one of the things we're doing is we have a sandbox solution. A sandbox will run a file and essentially try to see what that file is trying to do. When we're talking about our everyday computers, Windows, Mac, even Linux, that's a fairly easy thing to do, right? There's a lot of products out there that can do that. But if we go back to, again, the controllers, which speak a very specific language between them, and that language will change from one controller manufacturer to the other. Now we're talking about a completely different game. the OPSWAT sandbox can actually specifically target and detect any type of malware that's trying, for example, to target the Siemens controller. Prevention not based on detection. So again, probably one of the biggest points I'll hit today, you just can't rely on detection. There's a lot of ways hackers get really creative and they find ways to evade the traditional security control. And OPSWAT provides a solution where we just remove anything that can be used for an attack instead of trying to understand if it's being used for an attack. So again, zero tolerance, zero trust. Give you a quick example. If someone is sending me a PDF over email, that PDF has a JavaScript. JavaScripts can be used for an attack, and very commonly this is how the attack starts, is sending a file over email. Instead of trying to understand what that JavaScript is doing, I'm just going to remove it from the file and not take any chances. That's a very proven technology. Department of Homeland Security tried to break it, and we came up with about 98, almost 99% success. And usability design for OT. So very simple to deploy the OPSWAT solutions and very simple to manage the solutions to the point that OPSWAT can even manage those solutions for you. And one of the things we're doing, for example, is hosted OT SOC. Can tell you specifically a project where power generation facility, a new facility that was built, OPSWAT was involved from day one, just advising how to set things up correctly from the very beginning to actually providing some of the solutions and managing the solutions for the customer. And then we have the OPSWAT Academy, which aims to train people not necessarily on the OPSWAT products, but on the industry and on the challenges and why some of these things matter. Most of our classes are free, and I definitely recommend to go and check that out if you want to learn more about the challenges in protection of critical infrastructure. So we talked earlier about the Purdue model and what a typical network would look like in a manufacturing environment. So visualizing a little bit where OPSWAT fits in, the first thing we show here, developer tools. Anyone that develop their own software that can be supply chain attacks. Think about SolarWinds, for example, where the source code actually gets infected, and now they become a malware distributor, and all their customers are getting hit by that malware because they trusted that one vendor. And it can be as simple as I have a website that allows customers or users to upload files, and I want to integrate in a programmatic way, scan those files before I let them into my environment. We also have different ways to apply that technology out of the box, and we can apply that essentially to any place in the organization that can ingest files, right? It can be your storage, it can be a cloud-hosted application, of course, email and ICAP. So ICAP is a nice name to say we can intercept network traffic. So if someone is uploading a file to your system, or you have a user in the office downloading a file, literally plug and play. Takes us about half an hour to set this thing up. And then looking at the OT environment. So I mentioned our first step into the OT world was around 2010. That was the kiosk solution. So not only we provide a secure process to scan files coming into that OT environment, we provide the entire process. So we provide audit trails. We can tell you exactly who brought in the files, maybe who was their contact at the organization. And a lot of times that meant creating a new process to make sure we're doing this in a secure way. So any file that we're using to update the systems in the environment and so on will go through the kiosk system. We have means to make sure we're enforcing that traffic one way. A lot of times we don't want data to leave this environment, so we can make sure we only send files one way. And then we have other solutions to really protect the network. If you think about that Stuxnet example, the product like the OT Fuse here really controls the communication between those machines and limits that communication to which system can talk to what other systems, what language we allow them to talk, so what protocols can be used, and really reducing the option for something like Stuxnet to happen again. So worst case scenario, if a piece of the malicious software finds its way into our secure environment, we can make sure it won't replicate itself and do a bigger damage. Then for security operations, we have Malware Analyzer, which is essentially an orchestrator, allowing teams to integrate with all of the OPSWAT products, but also other tools. And normally that would be, SOC teams, they like data. They like to use as many tools as they can to get that data. And we can help, again, get that integration and easily connect everything together. So kind of one slide to show you everything with it. And again, anywhere where you can ingest a file or anywhere where a device can connect to your systems, we can stop that right there and make sure it is really secure and safe to use. So higher level in what we're doing, I mentioned trust no file and don't rely on detection. So that's the deep content disarm and reconstruct technology. I can call that CDR, and that was coined by Gartner. OPSWAT used to call that data sanitization, and of course we lined up with Gartner on the name of the technology. So again, really one of the only ways, if not the only way, to truly prevent unknown threats. There's about 500,000 new types of malware released every day. It's just insane to think that someone will claim to detect all of these new variations, and that before we started talking about sophisticated evasion techniques, right? Deep CDR really prevents that. So again, don't rely on detection. We'll take the file, we'll make sure the file structure is really what it should be. There's no executable hiding there, and no one tried to change the file structure and do something they shouldn't be doing with that file. And then removing anything that could potentially be used for an attack. So again, not relying on detection. When we do talk about detection and there's benefits there, we do want to try to detect any type of known malware, and OPSWAT is using multiple scan engines. We can provide that to customers to host in their environment. And again, we can live in completely offline environments. The benefit of multi-scanning. So first of all, the obvious is just the more AV engines I'm using, the better chances I have to catch any type of known threat. Other benefit that a lot of people are not aware of really is the time to detect an outbreak. So I mentioned new malware is being released every day, and the time for the different vendors to detect that new malware a lot of the times depends on the location. So if there's an outbreak in Romania today, Bitdefender, which is an AV company out of Romania, is probably going to pick that up and detect that new malware before other vendors. Now, how much faster that's going to be, that can be a matter of minutes. More realistically, probably a few hours before other vendors can detect it. Sometimes we see months that it takes them to add those signatures and detect that new malware. So really reducing the exposure and the time you are exposed to new outbreaks. Then I mentioned OT specific sandbox. There's a few more things we're adding on top of it. Everything is really focused on the file we're handling. And going back to our previous slide, we can easily apply that to anywhere we can ingest files. Our products are designed to be super simple for deployment, for implementation, and for management once it's implemented. You don't need to be a programmer or anything like that. You really don't need anything special to be able to manage our solutions and deploy them. I can, again, share with you from my experience in most cases. We'll do a POC where the OpsWatt engineers and sales engineers will kind of walk the customer through the deployment. Most of the times it will be set and forget. We'll configure everything we need during POC. I've seen cases where 5 years later and nothing changed because it's working. So, you know, if it's working, don't touch it. And I mentioned again, we can even provide managed solutions where there's really nothing you need to do besides plug that solution to the power, and OpsWatt will take it from there and completely manage it for the customer. So I mentioned OpsWatt Academy. I do recommend for everyone to go and check it out. We're covering anything from the IT world, network access control, to storage security, file upload security, and so on, to the SIP environment, so critical infrastructure protection, getting a little bit more into details in some of the things I covered today. And then we have our professional courses where customers and partners can learn more about the OpsWatt products. So the pro courses do cost money. I do believe we provide that for free for our partners. And these courses are the ones that really focus on the OpsWatt products. The free classes are really not focusing in any way on our products or anything like that. Really just aiming to educate people and provide another resource to educate anyone that wants to learn more about critical infrastructure protection. All right. I appreciate you all listening to me today. If you want to learn more about what OpsWatt is doing, how we're doing it, please feel free to reach out to Ingram or reach out to me, and I'd be happy to get on a call with you and dive a little bit more into details. I think we do have some time, and I'd be happy to get any questions, anything I talked about today. I hope you enjoyed that presentation. I'll pass it on to Jerry to manage that portion.
Awesome. Thank you so much. It was really comprehensive information. I hope everybody found some value in that. What we want to do is we want to be sure that we are able to address any questions that you have, and especially with the OpsWatt platform because of its unusual niche place in OT and SCADA and industrial controls. I want to be sure that we have ample time to do that, and it looks like we do. So Carlene, are there any questions in the chat?
Yes, we do have a question. Who are your main competitors in the OT space?
In the OT space, so again, it's a question I normally respond with which product are we talking about, because for each product from OpsWatt, we'll have different competitors. There's really not one company out there that can do everything that OpsWatt is doing. So you might have Honeywell competing with our kiosk. Symantec used to offer a similar solution. They don't offer that since Broadcom, for example, acquired them. That was the first product they discontinued. Then intrusion detection and prevention systems. There might be a couple of players in the market specifically for that technology, so it depends. So one that comes to mind might be Clarity, for example, but again, it's competing with a small subset of what OpsWatt can really offer. So thank you for the question. I appreciate that. I hope that answers the question. Do you have any more questions?
Yes, sorry, we do have another question. Beyond big impact industries like nuclear power, who would your more general target clients look like? And they give examples like cities or mining operations.
So that can be anything really, municipalities, enterprises. I would say probably the sweet spot is any enterprise that's about 5,000 employees and more. Typically, those organizations will have dedicated cybersecurity teams. We work closely with the federal government and then on the state level as well. Yeah, that's off the top of my mind.
Okay, great. And then we've got another one. How can a reseller partner become more proficient with this platform? How to present it or explain it?
So we have an onboarding and training process for our partners to enable our partners, teach them more about our products and what is it that we do. We can help set up labs and so on. And we normally like to stay close and offer support for customer engagement. So we encourage our partners to include us in that process as well.
Great. And then it looks like our last question, can an IT system have an adverse effect on CIS/OT systems?
Yes, of course. And in most cases, so I used a lot the example of a nuclear power plant, but think about the Colonial Pipeline and other examples where normally IT and OT will be connected in some way. And that's just a matter of convenience, right? I want to be able to manage all of my systems from a single place, not to mention work remote from home and so on. And yes, that's normally what happens, is that the breach will happen through an email. And again, hackers are talented enough to be able to replicate that and get all the way down to the bottom network, to the actual control system of the pumps, of the machines, and whatever that may be.
All right, thanks so much, Amit. I think that's the questions we had on my end.
Okay, thank you very much.
Yeah, and thank you, Amit, again. There are a couple more questions that that I got here, my end here. Can your product be used as an enterprise solution instead of just
Yes.
industrial controls or operational technology?
Yes, absolutely, and that's a good question. Thanks. Normally, what happens is, again, enterprise will be a sweet spot, I would say. And almost always when we start a project, we'll very quickly get the buy-in from other teams. So let's say if there's a development team that reached out to us because they're looking for that solution, they'll have other groups joining that POC, let's say, and almost always will end up being that central security stack for the entire organization. So that will become kind of the new business process in the backend for any file that's coming in, no matter where it's coming in from.
Okay, awesome. And then final question that I have here is, if an unknown threat is removed from a file through your CDR process, and that, let's say it's a link, and it's found to be safe, can the user get that back?
Yes, so our different integrations, not only aiming to make the deployment simple and fast, but we also add these type of options to the process. So if we're talking about an email, for example, you always have a way to either go back yourself as the user or go back to your IT team and ask for that file back. Can tell you personally, I've never run into a situation like that. So OPSWAT is using the same thing for our email system. I never had to go back to my IT team to ask for a file. But yes, there's always an option to keep that original file, especially when we're talking about situations where the chain of custody is important.
Got it. Okay, perfect. Well, that's all the questions that I know of. And if that's all that Carlene has, I'd like to thank everybody. Amit, thank you for taking the time to present. I want to thank our attendees. Today's the last session of our 4-part webinar. on Zero Trust, and we hope that you got something out of this for sure. Our goal is to enable and educate, and so that you can make good decisions about potential solutions that you can take to your clients. If the team, if our partner community has any input on additional series that you'd like to see, I'd love to hear from you. My email is here on the screen, Jimmy's as well. And please feel free to provide us some feedback and input so that we can make this a better outcome for future presentations. So with that, let's go ahead and call it a day. I appreciate everybody's time.
Thank you. Bye-bye.
Okay, thank you all. Take care.